Hello everyone, my name is Sharad. Today I am going to discuss about some tasks listed here for the machining of aluminium, carbon fiber weaving pattern and carbon fiber parts. This is the sweet spot graph for the feed rate and the speed. The green part shows the maximum MRR, best tool life and the surface finish. Moving toward the aluminium milling 6061T6, here is the data given for the SFM and the chip load per tooth. On the right hand side, formula for the speed and for the feed rate is given. Moving toward the aluminium milling 6061T6, tool dia, SFM chip load parameters are given here. With reference to the formula given in the last slide, I have calculated the spindle RPM and the feed rate, and also with the reference to the G-Wizard software. Here in the G-Wizard software, the material, tool dia, cut depth, I have defined all these in this, and chip load also. After simplifying the equation, we will get the RPM of 6478 and feed rate of 181 mm per minute. Moving toward the carbon fiber 1 mm, 2 mm, 3 mm milling, the calculations are given here. I have defined the tool dia, SFM chip load for the carbon fiber. The spindle RPM and feed rate can be calculated from the G-Wizard software. Here I have defined the material composite, then HSS end mill, tool dia 3 mm, cut depth. By simplifying the value, we get the 9877 RPM and feed rate of 454 mm per minute. The range for the spindle RPM and feed rate for the carbon fiber is high RPM of 8000 to 10,000 and high feed rate of 15 to 25 IPM. Next calculation is for the maple wood, that is a hard wood. Through the G-Wizard software, I have calculated all this value again. In the G-Wizard software, I have defined the surface speed, chip load, tool dia, tool and material, and we get the value of 11,460 and the feed rate of 249.6 mm per minute. Now moving toward the hard plastic, rigid PVC, plexi, polycarbonate, nylon. The spindle speed is 6,000 to 800 for small shape and medium shape, 10,000 to 14,000, but we have limit of 12,000 RPM with the machine. And chip load data is also given here. The tool series are also defined here. We can see in this data we have RPM and the feed rate also. Now moving toward the weaving pattern of carbon fiber, there are various number of carbon fiber pattern listed here. The simple one is 1 into 1 carbon fiber pattern, that is the under over pattern. The second one is 2 into 2 12 wave carbon fiber pattern. The braid is over under pattern. It is also used in the Apache 180 160 RTR. Next is harness setting. This is 4, 5 and 8. This is 4 HS, that is 4 over 1, 5 HS, that is 5 over 1 and 8 HS, that is 8 over 1. Next is 4 into 4 12 wave carbon fiber pattern. 4 into 4 12 will bend around curve better than 2 into 2 12 wave. Next one is unidirectional carbon fiber pattern. Where the force exerted on the object come from the one axis, we use this pattern. Next one is triaxial balanced carbon fiber pattern. In this, the orientation is 0 axial, plus 60 biased and minus 60 biased, as shown in the figure. This pattern is 2 over 2 under pattern and it is used in the aerospace engineering, sports equipment and automotive racing. Next is 1K into 3K plain wave carbon fiber pattern, which is 3K wrap and 1K fill. It is highly formable and wet out easily. Now moving toward the strength of carbon fiber, it depends on the 1K, 3K and 6K strengths. 12 wave per inch means 12 bundle per inch, and each bundle can contain 1000, 3000, 6000, 12,000 strands of carbon. Carbon fiber part using resin LY5052 and carbon fiber sheets. Compression molding. This is two-piece mold usually made of aluminum or steel pressed together the carbon fiber and the resin between two. You can see the example of CCS composite on the right hand side. This is the door for V22 Osprey. Next one is rigid bladder molding. Pre-packed material is applied to semi-rigid bladder and it is similar to the compression molding. The air pressure is used to force the laminate outward in the cavity and consolidate the material in the closed mold. Next one is the vacuum bagging. In this, the resin and the carbon fiber is packed together Vacuum bagging uses the resin infusion process where the vacuum pulls the resin through the small tube into the bag. Next one is filament winding. Filament winding can be used to make CFRP parts by winding filament around a mandrel or a core. These tubes are manufactured through the filament winding. Next one is RTM, that is resin transfer molding. The fiber perform or a dry fiber reinforcement is packed into a mold cavity that has the shape of the desired part. Here first the fabric is layered and transformed in a stabilized perform. Then the perform is transferred into mold and the resin is injected into it and followed by the curing process. Murcielago the Ventador LP7004 is manufactured using the RTM process of araldite, that is LY5052. Next one is basic parts of UAV. These are the different view of the propeller. This propeller is designed in SolidWorks using the loft feature and the 2D profiles. Next is the UAV wings. These UAV wings are also designed using the 2D sketches in different planes and by loft features. These are some examples of the UAV designs. Now moving toward the animated joint. This is the animated joint I have designed in the SolidWorks. One side is a driving mechanism and second one is a driven mechanism. Thank you.